And we're live. Welcome, everybody.
Smile and wave,
This
boys.
is the Coffee and Ham Radio Saturday morning zoo. Dun, dun, dun. I don't know. It's been
Okay.
over 1,000 shows, and we're kind of out of intros.
That's awesome. We used them all up, right?
Right.
Here
So
we
on
are.
today's show, we're going to talk to Nino and Tad. Nino is the brains behind the PCB, the NinoTNC, and I'm using acronyms like a mad flea. I don't know. I tried to rhyme. Don't do that anymore. Tad does all the documentation and the public outreach and probably a whole bunch of other stuff, and I'm probably shortchanging both of them. So I'm going to go ahead and introduce Nino to you. Nino, tell us a little bit more about all the stuff I left out about how awesome you are.
Oh, I'm a very average individual. Let's see. This is the TNC project kind of started as an extension of a hobby. I mean, this is all hobby space, right? This is not a career kind of thing. I was trained as an engineer in college, but I went to the Air Force, and I use electronics kind of as the keep me sane hobby. And Tad and I started working on this TNC project. Boy, it was almost, I guess, 10 years ago, and it's gained a little bit of traction. This is the workshop where I currently test and update firmware. So yeah, that's me. I'm a hobbyist firmware coder and amateur PCB designer.
So the main chip on the NinoTNC is a PIC, or what is it?
Yeah, it's a microchip DS PIC. It's the 256K or the 512K version. 28 pin leaded part. And we are using that one because it's available as a through-hole part. And we want to keep our TNC production super easy, low cost, and hobbyist amateur. And as long as there's a through-hole part available, we're gonna focus on that processor.
And then what language do you use on that chip?
Primarily C, a little bit of assembly code for the DSP instructions. The DSPIC is a really capable processor, even though I bet it's over a decade old in terms of the die design. It's
Well,
about
that's modern by ham radio standards.
Well, yeah, I guess so. But it's nothing close to what's available now in terms of cycles per second. It runs at about 66 megahertz, 66 million instructions per second. It has some hardware instructions that will do multiplication, add and multiply, kind of some of the basic DSP functions really quickly in just a handful of cycles. And if you harness those instructions, you can get a lot of DSP capability out of that chip relatively compared to other PICs that lack that DSP engine and the special instructions.
Okay. All right. Before we get too far into the weeds, I want to give Tad a chance to talk about how awesome he is, because I missed the mark. I can't speak enough about how awesome Tad is. And Tad's muted for some reason.
Apparently, Tad doesn't know how to work his microphone.
I don't.
Well, he's cradling it like the little baby that it is.
Well,
So
I
precious.
mean, if I did this, it would work just as well. Let's see. So I've been a ham for most of my life. I was involved in packet radio. I can't say I was there at the beginning. I was a user fairly early, but in the late '90s, I was one of the founders of the Northeast Digital Association. We had a very large data network using packet radio, AX25, 1200, 4800, 9600 baud, whatever was available. It was not mine. It was not even the club's. It was owned and operated by the individuals, and the club stuck a fork in people and tried to get the thing going. In 2001, we killed the club on purpose because most of the board of directors decided that it was no longer necessary because internet had taken over. I was one of the few people that cried about that, but we lacked the imagination to think that maybe the hams that were in the project that were left after people started diving away to do links over internet, the hams that were left probably could have kept the network going, or at least built a new network in its place. It wasn't for 14 years that I came to that, hey, wait a minute. By that point, I had moved twice. I moved to Orlando and then to Raleigh. And in 2014, I created the Tarpon domain names and the group's IO and started poking the whole idea. Myself and 3 other people went out and built packet radio nodes using G8 BPQ on a Raspberry Pi with TNC Pis and whatever TNCs we had laying around. We had PACCOMs and KPC3s and so on. The whole point of this was to have the network so that we could do engineering for it. What happened?
Doc, she just shot me.
Oh, yeah.
Straight through the heart.
Yeah.
Thanks,
Anyway,
thanks, Doc.
Thanks, Doc.
So basically, what we have, the Tarpon project has created a recipe and engineering and so on to build a network of stations that could be large. I could tell you, we talked for a little bit later about the kinds of packet radio there are and what's the difference between them. But Tarpon is not trying to build a network to connect all of the existing packet radio stations. We're trying to do something new, and we're trying to enhance the state of the art. Nino came into the project very early on. He and I collaborated on a thing that never went anywhere, which was to build a homebrew radio using single chip micros and amplifiers and filters and so on. Then Nino took that with the same processor, although he made a 9600 baud TNC as a demonstrator of what these things could do. And out of fear that Nino was going to run away and do something that wasn't related to our project, I kind of got the fork out again, and I talked him into making something that we could reproduce, and he made a 9600 baud TNC that we could use in concert with the TNC Pi. The TNC Pi would do 1200 baud, and the 9600 TNC would hook up to radios that could do that. At the time, we were using Direwolf for 9600 baud using Tate radios, and finding it very difficult to promote. One of the Tarpon things is to try to make an easy to build recipe for building packet radio networks. We wanted to, back in the 90s, we had a dichotomy. We had the builders and owners of the packet nodes, and we had the users. And by far, most of the people that did packet radio in New York, New Jersey, Massachusetts, Vermont, etc., Quebec, Ontario, were users of the system and didn't really have the keys or the knowledge or the confidence to build the network. So when it died, when the network aficionados, the people who knew how things worked, found out about, got on the internet with cable modems, they pretty much left the project, and the people who were left didn't know how to build nodes, and the confidence that we needed a network in the first place killed the project. So anyway, Tarpon is all about not using the internet, because we were screwed by that before. So we came into this with the idea that having the internet as part of your network, or part of ham radio at all, in terms of a transparent connectivity between the two, was actually a way to break your project. Why would someone link Rochester to Syracuse with the intermediate stations at Canandaigua and so on, when you could just do the internet between the two? And furthermore, why would anybody use packet radio to try to get to a service when that same service is on the internet? So we wanted the thing to be both attractive and require ham radio to participate in it. So when Nino came into the thing with this TNC, I mean, he was in it early on, but when he got the TNC working, I looked at that as an opportunity to be attractive. We have other projects, none of them as grand as what Nino did, but we have other projects that are trying to make it more obvious that your node needs service, for example, that it's running. We have software projects, we have minor hardware projects, and the point of this thing is to make running a packet node fun and easy and cheap. And we're driving all 3 of those directions. We haven't made it really in any of those directions, but we're driving all of them. And so that's what Tarpon's about. It's not about a particular network. It's about making it easy for people to build networks. And so that's the NinoTNC, obviously making the thing easy to build, for example. I think we've got that checkbox. Easy to operate, check. Thank you, Nino. Thank you, everybody else who participated in poking at us. And that's kind of cool. It's a great advertiser. Heck, more people know about Tarpon because of NinoTNC than anything else we've done. So that's where we are.
Hey, Tad, I see a question from K2AUB. Is there an estimated ETA for more NinoTNCs? yeah, very perceptive. The Etsy store ran out of stock last week. I'm the whole company for this project, including everything else I do to actually run and maintain a house and a family. So it's going to be a couple weeks before there's more stock. I actually have, I've got more boards. I've got a couple hundred more boards. I need to order more processors. But before we sell more TNCs, we're actually going to update our assembly instructions because we've changed the circuit board in a very minor way, and we're letting this out of stock situation be sort of our transition point to a new part. Sorry, I probably just made noise on the microphone. All over the place here, but the push-to-talk transistor that we were using for a while is about to be discontinued. I think it is discontinued. Yeah. And so we're moving to this little 3-pin part that's it's a high-power MOSFET to do the keying of the radio. And I might have the old part here somewhere.
I have TNCs with the old part.
Yeah, I do too, I think.
Is that the weird 4-pin, 3-pin thing, or is that another
that's
transistor?
right. That's right.
Where is that thing? There
it is. That little 4-pin thing that Tad's showing.
Yeah. So 2 of the pins are actually physically joined together on the circuit on the chip itself, and then the other 2 are free.
So it's a 3-pin part electrically.
In a 4-pin
goes
package,
into a 4-pin hole.
Yeah,
which is cute, and the thing worked great. But so we'll just have to change the board with those 3 pieces. So the circuit board is not.
Those parts are designed to sink a lot of current.
See that,
and dissipate a lot of heat. Yeah, it's there.
So yeah, the 3-pin thing is right there.
Mm-hmm. So we've got to get our act together with that and make sure the instructions work. I've got to build one of the boards to make sure it actually works before I start.
I actually got parts on the way for 2, and I pondered building it with my existing parts, but I can actually photograph and move forward and redo the docks. I'm going to probably get work on that by next Sunday. I can't work on it this week. And actually am behind on a project for my day job, so I'm trying to scramble to catch up with that.
I understand how that goes. So Tad mentioned the first TNC that we made. This is one of the original ones. I'm going to disconnect.
I got an original one here. Hang on.
Well, this one's in current service as the programming jig for all the chips that I send out. In fact, the most current firmware will still run on this thing. It's a little bit less refined of a design, and I've cobbled in a 0 insertion force socket to pop the chips in and out real quick. Yeah, there it is. So that's where, I don't know, that's where the production side of the project sort of started. There were some prototypes before that were wire wrapped that actually worked. That was kind of fun. I think I still have those somewhere in a bucket in this room. There's another early version with the different USB connector.
Was that a Pi TNC though? Was that part of the evolution? Was the Pi TNC or
no? That was a totally separate project and product by somebody else.
Different people. Yeah, G8BPQ and W2FS did the TNC Pi. Really the things that we had a lot of TNC Pis in our network, and one of the things that I thought was useful and important was that that the NinoTNC would be a direct swap in the same containers, because we had a lot of boxes that were that held the TNC Pi. And also, of course, the hobby market would go nuts if we were close, but not exactly Raspberry Pi hole pattern. The programming of the PIC can be altered, and it can. In fact, there's an online bootloader. I'm answering Chris's question. There's 2 different ways to run the bootloader. It's built into the Tarpon install. There's a separate Raspberry Pi install that just does the bootloader, and then there's you can go to GitHub and download the Python script and run it on whatever machine you can run Python on.
Yeah, we talked about the firmware earlier. It's written in C and assembly. I think we're going to just open source it here in the next, 0 to infinity months.
Right.
Good schedule.
When you get around to it.
Yeah, before the sun goes nova.
That's right. Yeah, we can set that stake in the ground.
Hopefully, right.
All of the firmware, I tried to build this from the ground up without using libraries, vendor libraries, and that kind of thing. So I guess you would call that bare metal for the most part. I'm the author of most of it. I think that some code that Tad helped me with is somewhere in there. I don't know. We were doing, remember the Morse code ident and that kind of
Yeah,
stuff?
yeah.
I don't even know if that's still in there. In any case, I'd like to clean it up before we make it open source. Clean it up, meaning,
Your babies, yeah.
yeah. This
Well,
is
and there'll be a lot of
I've done that.
judgmental. There'll be a
Don't
lot
look
of
at my
judgment on your
And-
code.
Exactly, and I'm not a professional programmer.
Why
So-
did this
back
guy
when I
do
didn't know
this? That's
anything.
totally wrong.
So
And the funny thing is, when you read the code, if you're a programmer, you'll see my coding style evolve.
Evolve over time. Yep,
over
I've been
time, commenting, increasing, decreasing, whatever.
there. When they hired the new guy on your team after you've been there for 6 months, you're like, no, I'm kind of embarrassed, but I was here.
one
Like,
thing
I had so much stuff
ponder
to deal
about,
with.
if the thing was open source and we could find other people who like doing that kind of thing, the hardware is almost perfect, I think, for doing touchtone decode and private line or CTCSS decode and encode. It would be an awesome accessory to a repeater controller.
Well, it is designed as a voice band thing, right? The original, the whole design is based on utilizing radios that are cheap and plentiful to push data, or anything else that fits into the voice bandwidth of these cheap secondhand radios. So typically that's about 3,000 kilohertz wide bandwidth. There's a little bit more available because we also had the goal of using the faster FSK modes that were traditionally untouchable, right? I got interested in this as a side project because my early grade school education was influenced a lot by getting my amateur radio license. Then one of the folks who helped me through that process loaned me a dumb terminal and one of the early MFJ TNCs and an 11 element 2-meter Yagi to point at the nearest packet node. I mean, then this was late 80s, early 90s, probably early 90s. There was no internet out in the farmhouse where I lived. There was no internet anywhere in my little town, right? So this was a very interesting thing. Then zoom fast forward through college and an Air Force career, the internet happened, and I had always enjoyed that experience of using that first packet terminal, right, as a kid. And I was wondering, hey, does this still exist? Is this still out there? Tad's project, the Tarpon project at the time when we started talking to each other, I found it by just Googling packet radio in, whatever year, 10 years ago, 8 years ago, whenever. And basically it's the only thing that came up, or at least it was in the top 3 hits on the internet at that time of what are people doing with packet radio other than APRS.
So we have, thank you, that was a perfect segue. What is a TNC? Because we've had several people in the chat who,
Like
and
very
several
basic
helpful
level.
people said terminal
Yeah.
node controller, which doesn't actually tell you what a TNC is.
It doesn't answer the question. It's
Yeah.
like being helpful but not helpful.
And this is also, there's some semantics involved in terms of what
And
a
packet radio, too, as well.
That's
Yeah.
actually a good question for me. I have is, what is packet radio? Because it's different things to different people.
For sure. So first, if you say the word packet, I think that goes back to the idea that you have a fixed amount of data. It starts and it ends. It's in a little batch and it goes out at once. And in some method, you can say, oh, I have enough information here to say all the data's here, right? Typically, that's
CRT checksum,
a
whatever.
cyclic redundancy check, or you can use some forward error correction, other methods of figuring out, yeah, there's a high probability that I have the whole packet. Everything that I send in this burst is here. You compare that or contrast it with an old ham digital mode like RTTY, radio teletype, right? Where it's character by character, the tones are modulated, whatever comes out on the other end is just a matter of luck. Did you get the whole sentence or not? Is that all the person sent? You're kind of using your own interpretation to say, I think this is a complete message, especially when the signal to noise ratio is really low, meaning it's a really scratchy signal, right? So packet means I know I got the whole message, and that message is a packet, all right? Inside of a packet, the AX25 standard defines some metadata that goes at the front, the header, with your call sign, the call sign where you want it to go, and some control and protocol information. And then there's, quote, the payload, which is all the stuff, all the information that you want to send to the other station. So that's what I think of when I think of packet. It means we're talking not about an asynchronous stream of bits. We're not talking about an asynchronous stream of bytes or characters.
Differentiated from RTTY.
Yeah, we're talking about a whole chunk of
Block.
information. Yeah, that we
A
can
block
say,
of data.
I got the whole chunk, and I know I got the whole chunk, or at least I'm, 1 in a million sure, or 1 in 10 million sure that I got the whole chunk.
To summarize that little segment, the bottom line is if your system thinks that it got a packet, it got all of it, it doesn't necessarily deal with I didn't get enough of it, or I got errors, because that means that you throw it away. And the way that all packet radio or packet anything works is they discard the message. They may know that something tried to come in, but they don't necessarily know it was to me. Was it this one coming to me, or was it going somewhere else? Because the message was corrupt in some way, I'll discard all information about it, accepting that something was coming in. In ham radio, AX25, generally speaking, you don't even know that something was coming in if it didn't come in perfectly.
And that's, there's really interesting information theory behind some of this. And in starting to try to design a modem, I got to touch on a little bit of it. If you make an assumption that, I've heard this pattern of bits, so a packet must be starting, well, then your probability of receiving the packet that's actually starting, but starting a little bit later, goes down, right? When you lock up your system and say, ooh, I'm starting to receive a packet. So the bottom line on that is the TNC, the modem, doesn't know that it has received a packet until the packet is complete and the checksum is computed, and it says, yeah, that's a valid checksum. So the last 1,000 bits of data were a packet. Here you go, I'm going to send that along. All right, and we're talking about the most basic AX25 style packets. We can talk about forward error correction and IL2P, which is an extension. It kind of grows off of AX25 to add some forward error correction. It's just one way to add error correction, which means you add a little bit more redundant information into the packet, and you do that in a method that allows the device receiving it to say, I think I got a packet. It looks like some of the information has been distorted, but I have this information over here, and I can do some math on this and say, I know what that information was. It all checks. I'm sending it to the next step of the process. And that can make a link more efficient because you spend less time resending broken packets.
So the TNC, the name of it as a terminal node controller, the reason why it was that it was accepted that you would have a machine of some kind, usually a dumb terminal, plugged into the TNC, which would then go over the radio to another TNC, which we plugged into another dumb terminal or computer. So a dumb terminal, to go back in the 70s and 60s, a dumb terminal meant that anything that comes through its port, it gets displayed, and anything that goes on the keyboard gets sent. There would be no processing to do screen rendering or put this character here, put that character there. None of that. So dumb terminal was dumb. And those were cheap because when PCs and Apples and CPM started coming out, dumb terminals were relegated to the scrap heap, and so the hams could get them and use them to drive their TNC. The TNC had the intelligence to do the packet radio operation, but also had command processing, so you could say, this is my call sign, or I want to connect to Fred via Joe. That capability was built into the TNC. Now later, Phil Karn wrote I think it was him that wrote it. It was. Wrote a program called KISS, Keep It Simple Stupid, which made the TNC dumber and put more of the intelligence into the computer and less into the TNC. So the TNC was now a jack of all trades, Swiss Army knife deal, where it could take traffic coming in. If it in fact CRC'd, still has that, is it a good packet or a bad decision. If it's a good packet, it shoves it over to the port to the computer, and it's up to the computer to decide whether this is a good packet for me. Is it a packet that I want to display? Is it a packet I want to answer? Is it a packet I want to pass on to the internet? All of that's up to the PC. The TNC does not have any storage, for that matter, of the packet. If it goes out the port and it's gone. So this is very different from the TNC of the 80s. Now, the NinoTNC and a couple of others, including some software projects that emulated the TNC, do not do the command processing functions of the old at all. There's no KISS was a mode in the 80s and 90s. Now this is all the thing does. So there is no expectation that there's a mail storage or a call sign setting or any of that. So the big difference between a TNC and a KISS TNC is a TNC knew who it was. So you'd say, this is KA2DEW's TNC. Any traffic that goes to KA2DEW is interesting. Anything else is fluff or things I could monitor, but it's not to me. A KISS TNC has no idea who it is, or at least usually. And the NinoTNC actually has one exception where it knows who's sending, and that's just a feature we added for multi-baud capability because we didn't want to. Yep, go ahead.
So we have a couple of questions, and one of them was, and I think you kind of addressed this, but are there plans to allow the NinoTNC to utilize the increased speed the FCC is allowing us now on HF?
So the TNC does do 1200 baud on SSB now.
Already there? Okay.
Yeah.
It also does 300 baud.
Because I want to get up to FidoNet speeds, baby. I mean, 9600 or die. I'm just saying.
There's some interesting limitations about HF. The first one is you still are limited to voice bandwidth. So we could crush things in there and make more bits at the expense of signal to noise ratio. But there is math and so on that could be done to make more bits that doesn't cost you signal to noise ratio. We'll see how that goes. The biggest limitation or feature of
the encoding, I would imagine.
The biggest thing is that on HF is that there's no spectrum available for two hams to claim where they get to keep it forever. On VHF, because of the very local nature of your transmissions, you can actually claim a frequency. I mean, heck, the repeater coordinators are all about that, giving this pair of frequencies to this agency or this ham or this club. On HF, we can't do that. So we can't guarantee that you could even bring the network up at 11 o'clock at night on some evening like you did last evening because the frequency's in use. So HF, you have to wait and you have to be permissive about the frequency. Whereas on VHF, we can actually say, no, I'm going to transmit because I don't hear anything. And I'm going to keep doing that on and off for the next year. So it's a very different world. So in terms of the packet modem, the TNC, the NinoTNC, yes, HF support. In terms of Tarpon, it's not the same. It's supported differently than VHF.
And the Pactor modems are great examples of HF modems that are really smart and speed adaptive, kind of expensive, but also Vera HF is a PSK modem used on HF that can be fairly fast in good conditions. There are tons of challenges when you start to design a waveform and a modulation demodulation system for HF, because every HF band has different characteristics at different times of the day. And so it really depends what your goals are for the system to say, well, I'm adding some HF capability to this project. And we do have HF capability in the NinoTNC all the way up to 2400 bits per second, which uses a 1200 symbol per second QPSK, quadrature phase shift keying waveform, and IL2P. In perfect conditions, that works okay. You can use it on near vertical incidence skywave on 7 megahertz. You can use it on actual skywave in the higher frequencies using skip. I've done some testing around the US using SDRs at distant stations as the receivers, decoding what I can hear over the internet from my station at home. And it works. The use cases are limited, or at least we haven't thought through that all the way, and a lot more could be done to make the modem more effective. for different kinds of distortion you encounter in different HF regimes.
So there's a couple of factors on HF that are or players on HF that are worth considering. NinoTNC is definitely not the big one. And a lot of it has to do with the way you're operating on HF. In many packet radio modes, you have multiple stations on the frequency, all using the spectrum, sharing it over a short period of time. So you could have multiple conversations going on that will interfere with each other, but they won't show up at each other's stations because of the way packet works. You don't see other people's conversations unless you want to. So you could have a dozen conversations plying over a 20-minute period where they all have started before the period and they're all continuing after the period. And you can correct me if I'm wrong, but Pactor and Vera have in common the fact that it's two-way even while you're transmitting your message. Right, you send a message, the other end's telling you, I got this part, I got that part, I got this part, I got that part. And it's a selective ARQ, I think it's called, where it acknowledges the individual piece in real time as you're going. And that allows the TNC or the whatever the software that runs the modem to adapt to the conditions of the not only the band conditions, but also the audio path through the radio, so that you can frequency equalize and so on to make it so that it works. And that kind of requires that you're dedicated, the channel is yours during the operation. It doesn't share the channel like a 1200 baud AX25 TNC would. And that's interesting because it works very well. In most of VHF, what would be called packet radio, and this is one of the reasons I had the question earlier, what is packet radio? But in most of VHF, what you'd call packet radio, there's an expectation that you're sharing the channel and that your channel is shareable. The Tarpon project went a different way with that, and so did NITA, the Northeast Digital Association. In NITA, the backbones were dedicated to backbonery. And not only that, you would only have two stations on each backbone. So if you had a link through Syracuse, for example, you'd have a westbound connection through Canandaigua and an eastbound connection to Utica, and they would be on different frequencies, different radios, so they wouldn't interfere with each other. So you could simultaneously be transmitting in both directions. So anyway, getting off of HF, back to HF for a second. So if you wanted to have that quality of connection, a backbone connection on HF, you'd pretty much have to claim a frequency and camp on it forever. I don't know what the rules are with that. It's certainly not nice on 20 meters or 40 meters because there's not enough spectrum. The other thing about HF is that in order to operate full automatic in a backbone capacity where stations who aren't the owner of the equipment are passing through and can expect that the system is up all the time, in order to do that on HF, you have to be in a very narrow set of frequencies, in the United States anyway, a very narrow set of frequencies where full auto operation is allowed. And those frequencies are in use. So we can't just say, I'm going to make a new one and I'm going to leave it up all the time, because that would be completely rude. So on VHF, we can do that. HF, we cannot. And that makes a huge difference. It's pretty much manual operation for most stations on doing digital on HF. Did I have that right?
So,
sound familiar?
Yeah. So one of the things that people are curious about, on the NinoTNC, what separates something like the Nino with a USB connection and the 9-pin connection from something like any of the plethora of other TNCs, the ones that T.O. and I have had on his show?
Like
obviously, it has USB,
something?
which makes it way far futuristic from the other ones I've seen.
Well, KPC3 has that. Okay, so I recognize that one. The KPC3 does have USB now, if you get a new one. There are several things that are unique about the NinoTNC. One of them is only KISS. So there are other TNCs that are only KISS, but that one isn't one of them. The time wave is and the AE, the PK232 and the KPC3 all have all sorts of an intelligence inside. They can serve as a bulletin board, for example.
Right. Whereas the Nino is just doing the KISS functionality. There's no, obviously there's no BBS or anything in there. If you crammed that into that tiny package, I would have been truly amazed.
Well, there's no reason we couldn't. The objective of the project is a versatile, inexpensive packet radio
So-
KISS TNC. So that didn't come into the, but it's that CPU is plenty big. It's way bigger than the MFJ 1270B, for example, which has a
Yeah,
button.
but it's using that capability to do digital filtering that was done with coils,
with external
capacitors,
motor.
Right. Yeah.
and
Right.
Yeah, but still, if you think about how much memory the Z80 and the little AKK chip, there's plenty in there if you wanted to.
So what about migrating? And I'm asking this from ignorance. I have no idea if it's feasible or if there's a reason to. What about migrating it to something like a Pi Pico or even a regular Pi? Would that benefit it in any way? You could add in BBS functionality, for example, or some other stuff. I don't know.
it just becomes a completely different project. It's absolutely possible. I'm not sure if the Pico actually has, if it would be a big benefit, to be honest.
Yeah, I don't know if that's a good
but there are
choice or
other
not. I
chips
just
that
thought of
would
that
But
one.
there is more capable hardware available now that you could do a lot more with. It's just a completely different project that would require fabrication outside of individual workshops. It would
Well,
require
the
a real
TNC
company.
The TNC Pi 9K6 is what you're asking about. That
I don't know.
exists. That
I don't-
exists.
Never heard of it until you guys mentioned it a while ago.
Yeah, the TNC Pi 9K6 is, there's a club in Utah, I can't remember, that is selling the thing. G8BPQ had his hand in it at one point. G8BPQ is a software author from England that's been doing this software for packet radio since the late 80s. And he's still on it, and very prolific guy. But anyway, he had a lot to do with the TNC Pi, and he had a lot to do with the TNC Pi 9K6. The TNC Pi 9K6 uses a daughter card that looks very much like the Pico. I don't know which one it is, but it's one of those. It has a USB connector mounted on the board with the processor, and the NinoTNC is an awesome kit. We've polished it from top to bottom, and I don't. The 9K6 is not the same. It, for one thing, the CPU module is a lot of the project, and it's just not a kit. I mean, it's kind of neat that someone actually makes a good kit. So,
Right. Well, yeah.
there was a
Obviously,
period of time when
the
nobody
kit
did.
part has a lot of interest for hams. You know, I was just curious how we ended up with the hardware platform we're on. If it was because they're focusing on a kit, or
Yeah,
you know,
actually, it's personalities and objectives, right? And it started out with my objective of having a hobby, not really a company. I make money in other ways, and I like to just escape to the hobby
oh
area
yeah,
and do that
perfectly
kind of
fine.
stuff.
Yeah.
And so we intentionally picked components that were available in a way that could be assembled by most amateurs. And when that becomes something that you assemble, and then you say, if this thing's going to work, send me money, then it better work, right? And you're going to have to front a lot of money to get it assembled, tested, blah, blah, blah. Documentation is harder. So it's just beyond the scope of
What you guys wanna mess with,
at
yeah.
the time when it started, and Tad's objectives, right, for the network that he's working on. And
Well,
the
I
network
got to
project.
say now the kit, and we have said this on TO's show on Nuggets more than once. The kit is awesome. The documentation is just spot on. Probably some of the best. I've been reading technical documentation most of my life, and it looks like you didn't miss anything. I'm amazed because that is some of the best tech documentation I've ever read.
So
It was straightforward and easy to understand, and I built
That's
the
all
kit.
Tad's fault.
And the damn thing worked out. When I put the juice to it the first time it did the thing, I'm like, "Ooh, angels are singing."
I really appreciate that. It has
So
been
it's-
a lot
it's
of
a great
fun, and
kit.
a lot of it is because of the great feedback that we've gotten. Yet it's funny. Nino is doing this firmware as a hobby because it's not his day job. I do documentation, web pages, the optimization of the packet radio network and the nodes is my is my thing. But my profession is I'm a firmware engineer. So,
Well,
so,
bless your heart, you exceeded expectations there, Tad, because
I'm not doing it. I haven't done.
an engineer wrote this. Holy crap!
I've done practically no firmware. Done practically no firmware on this project. So
Hey,
it's-
I want to backtrack, 3 minutes just to throw a shout out to the UK amateurs that are using the
gosh,
Nino
yeah.
TNC, because we were talking about HF. There
Yeah.
is a healthy network of HF bulletin boards talking to each other in the United Kingdom and a little bit of mainland Europe, I think, that have overnight mail transfer using Nino TNCs on 40 megahertz. And
Holy
they're-
FidoNet, baby.
their licensing structure is different than ours, so they can actually carve out little slices of spectrum and say, hey, this slice of spectrum is going to do this thing, and we're just going to leave these systems running. Different rules, right? It's not the United States. And there's a healthy use of that over in the United Kingdom. They're using slow speeds, but they're using some of the newer modes that are a little bit more robust in the TNC for that.
Yeah.
Oh, that's cool.
Yeah,
To
it's
do
really
it
cool.
like that.
the online amateur radio community UK. They have a great Discord server and a web page, and they actually, I think their focus may be in education and licensing.
Yeah, it's just a ham interest group, I think, and it's
But
kind
they-
of
but they-
all over the hobby. Yeah.
They went nuts for the Nino TNC, and they've been fabulous. Before the Nino TNC, they were already opening the door for 9600 packet, and we took full advantage of the materials that Tom and the group over there have constructed. So
Their
yeah,
motivation is responsible for a lot of the development in terms of feedback to the firmware in the last 2 years.
Yeah,
We've developed new
absolutely.
modes, and we've fixed bugs and things that they've requested and they've identified. Interestingly, the 2-meter channel allocations in the United Kingdom are all narrowband, right? They're all 12.5 kilohertz. So wide FM modes aren't really preferred. I don't think they're even allowed in the United Kingdom. So we developed some narrow FM modes just for them to try out and use, and some of those are being exercised. It's just a lot of fun seeing how people use this thing all over the place.
Yeah, it's been fabulous working with them, and I hope it will continue to be. Yeah, they had us, Nino and I, on their program, their whatever their meeting. They used Discord and YouTube, and you can actually find them oarc.uk on YouTube and on the web. But anyway, this has been a good project. So I wanted to touch on what packet radio is again. I've heard that packet radio is bulletin boards and networks that anybody could randomly show up and traverse user accessible stuff on with 1200 baud X25 on 2 meters with single frequency. And anything that deviates from that isn't packet radio, which of course technically that's far from true. There's a lot of ways to operate data on ham radio or in any medium. If you have a channel and you have people who send traffic to it infrequently, and more importantly, they don't care or they don't have any system for monitoring to prove that the data got there. But that actually works rather well with lots of people on the channel, because there's no failure condition caused by too many people on the channel. APRS at the Dayton Hamvention, for example, there are hundreds of stations beaconing, and because they more or less are redundantly transmitting once a minute or once every 10 minutes or once every hour, they're sending a position report. If you miss one, you make it up later by figuring out, oh wait, they moved past that point. They must have been, gone through there in the first place. There's a lot of systems in the house, for example, Zigbee and so on, where you push an on switch and it sends out a blast that says, hey, the switch is now on. If it doesn't get through, that's okay. It'll get through a second later. But the on switch does not get an acknowledgement that from the lights or whatever else was on the system. It didn't even know what lights or motors or whatever it's controlling. It just sends out channel 1, unit 5 on. Those systems are great because congestion doesn't kill them. The way we were using packet in the 80s, the TAPR TNC, everybody on 145.01 in the United States, that method had a problem that when it got many users at the same time, it crashed. And people who were operating packet in the 90s with that mode, not APRS, but with the I need an acknowledgement that I sent this message mode, would get star disconnected frequently when they operated, especially if it was during prime time. Sometimes things work so badly that people abandon the network until it stopped, until nobody was using it, and someone would say, hey, let's see if I can get this far this time, and they DX it. As soon as anybody monitoring the channel saw that it was working again, they'd all jump on, and 5 minutes later it would crash because there's too many people using it. That was a familiar thing that the Northeast Digital Association tried to invent out of existence successfully. The only thing that got them was the coming of the cable modem, which we were completely unprepared for. So the thing is, there's other kinds of packet. I call them sparse and saturated modes. Saturated mode where it's expected that you can occupy the channel and nobody will complain. Sparse mode is it's expected that you're going to make single transmissions and not expect an acknowledgement. So APRS runs in sparse mode and so on. The dedicated channel versus a shared channel in congested mode is the difference between high capacity and continuous operation and low capacity and frequent failure. So if you could actually only have two stations on the channel, back and forth, brap, 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 you don't have to wait for a third party to jump in and share the channel. So you're glomming onto it with both hands. I'm pretty sure that's the way Vera works. When it gets on doing, it's basically packet radio using Vera modems. When it's talking to a WinLink station, it owns the channel for the duration of the contact.
I'm not sure. I mean, that sounds right. I've never used Vera, but
that works if you do it.
It does
that
work,
way.
yeah.
So there's a fairly stiff resentment or reaction to dedicated use of a VHF channel, even though the range is only 20 or 40 miles. But it's accepted in Vera and Pactor, which is okay. So anyway, the project that Nino and I are working on, the Tarpon project, is about coming up with designs for packet radio running in saturated mode where everybody can use the network at the same time, and it doesn't crash. And we're trying to optimize this for performance and cost, as well as fun. So taking those three things. Now, one of the questions you might ask is, how much does this cost? How many people have to be involved to do statewide, say in a medium-sized state like North Carolina or Virginia? And why would you do it? It's a lot of fun. But the biggest thing is that it's a project that hams can do and work together. They're geographically dispersed, but they're tight-knit by virtue. They're building their own land. They're building their own network. Mm-hmm. This is a social project. The NC Packet group, which I'm also part of, has a buzz phrase on our bumper stickers, as a matter of fact. If I can find one. There you go. Check out that bumper sticker.
Nice.
So that's kind of what we're pushing for. And the neat thing about it, and I could say this, there's a lot of people that don't want to do packet. They heard bad things about it or saw bad things about it in the 90s or 80s, and they don't want to play a part of it. The thing that's neat about this is it's extremely attractive to young people. I would venture to say that the NC Packet Club is the youngest club in North Carolina. If you go to one of our lunch meetings, it's really kind of neat. Now, I wouldn't say it's in the 20s, but the average age is probably in the upper 40s, which is probably 25 years younger than the average club. It's scary. Ham radio could be suffering from this, and NC Packet has done a pretty good job of making it fun for new hams or for attracting hams, people to the hobby, because hey, look at this project we get to work on. We get to work on it. We get to control it. We get to design it. We get to mod it. We get to hack it. Hack it, packet. That's actually not a bad club name. Anyway.
So Nino's had, before the show, he showed that he's got some demo stuff available. Can we see some of this stuff in action?
Sure thing.
I have demo stuff too, but go ahead, Nino.
Yeah, I think a good
Don't
thing
fight,
to start
guys.
with something practical. One of the early challenges we tried to solve in a graceful way was how to set the deviation of your FM radio with some of the faster packet modes. So I think I could screen share and do a little demo of setting deviation on a TNC. Does that work as a quick demo? There'll be some beeps and bloops
Yeah, sure.
and some SDR screenshots,
Yeah.
that kind of thing.
Definitely.
All right.
So when we talk about AX25, which is what packet radio is, that seems to be a fairly wide definition of a bunch of different transport protocols. So AX25 is essentially the network and the
It's like TCP/IP.
layer 2 and 3, and AX25 fits kind of somewhere between 3 and 4. It's part of the-
AX25 is 2.
It's 2. So it's replacing MAC addresses in Ethernet. Okay.
Yeah, it's basically switch to switch over Ethernet. That's layer 2.
Okay. So, yeah. All right. So having a wide area, and there were some comments rolling by. So yeah, we could do file sharing over AX25. It would take 8 days to get a JPEG, but
Well,
it would be cool.
necessarily. No, if you do it on our network, we can transfer at a 1200 baud. We can transfer 25 characters per second, which is megabytes per day. You can 25 times 3600. How big is that? Big
So
enough.
Commodore 64 size pictures would only take a day.
Right.
I mean, it's still pretty. That's pretty slow. 25 characters.
Yeah. So yeah, pictures worth 1,000 words. Yeah, but it costs 1,000,000 words. What are you talking about?
Right. Okay. And AX25, does that predate X25? That's an
No.
offshoot of X25?
It's an offshoot of X25.
Yeah. I was thinking that.
The A is
that-
amateur.
I did not know that. That makes perfect sense. I never knew where the A came from. I never asked anybody either. But yeah, okay. That makes sense.
So you can do lots of different kinds of networks across an AX25 link. But AX25 defines the link. So if you have 3 stations A, B, and C, and A wants to talk to C, AX25 actually has a mod to it that lets you digipede through B. But if you're doing anything other than digipeating through B, it's not just AX25. It's AX25 with NetROM or TCP/IP or something. So that
All right,
that
Nino, show us what you got.
yeah, what's the
So can you see my screen? It should be a waterfall.
No, we see your.
no, hang on one
icon
second.
2AT.
We see your manly arm and a screwdriver.
Okay, great. Well, that's it. That's all. I'm done. No.
And that Casio watch you're pimping there, son.
Hey, man. Air Force issued a long time ago.
Right?
So we've got a TNC here. I'm going to turn this down.
We can't hear the squelch noise anyway. The system's muting it.
Can you hear me?
I hear
Yes.
you
Yeah.
perfectly.
Okay. So I've got this TNC hooked up to a
The
Raspberry
blue
Pi.
box. The
Yeah.
green box.
Raspberry Pi TNC. This is hooked up to an ICOM or a Yaesu 2-meter radio through some attenuators out to an antenna. It's set to 1200 baud AX25 mode, and I'll just do a demo of setting the deviation to 3 kilohertz using the Bessel null. So when you push the test button on the TNC, it generates a tone and transmits it.
That's a feature that we put into the NinoTNC. It's
And
not
I'll-
no other TNC in the world, so far as I know, has that feature.
So right now you don't hear anything because I've got the deviation turned down to 0, but it's transmitting. You can't hear anything. If I let go, it's going to send a packet in whatever mode I've got selected.
Which is also transmit level down to 0.
All right, so I'm going to turn the volume up on this ancient ICOM IC2A that's set to the same frequency. If I start to increase the deviation, you'll start to hear something. So I'm turning.
Yep, hear the tone.
All right. So that tone is generated by the TNC as a tool to set deviation. You could just set it by ear by listening to the HT. Turn it up until it doesn't get any louder, then back it off a little bit, and you found whatever the maximum deviation is for your radio, if that's your goal. Tio, is there a way that you can share my screen? Is that
There is,
possible?
but I need you to take some action on that. At the bottom of
Yeah.
your web browser, there's a present button.
Uh-huh.
If you click that and then click share screen, and then you can share a browser tab or you can share the entire screen. Make sure
Okay.
there's nothing incriminating on your screen,
Right.
like credit card numbers or anything.
Right.
Text from your girlfriend.
Questionable websites.
Conversations with the foreigners, you shouldn't be texting.
Right.
Let's see. I'm going to share entire screen. I'm going
That you're
to
selling
allow.
TikTok stock short.
The secret's not out yet. Share screen. Share screen. I'm going to entire screen.
Ed, I think you're the one that has to delete your browser
Wow.
history. I've talked to you in person.
Yeah. Have we? We have met Ed.
See, now you're
Now
sharing
we
us.
see an infinite window of death. All right.
Yeah.
There we
There you
go.
go.
That's an
Waterfall.
SDR. All right.
Yes.
Looking good.
So let's see. Here we go. Yeah. So when I hit the test button, I'm pushing the test button on the TNC now. You see the carrier, because I've got the deviation set to 0 on the TNC. I let go. It sends a little burst of data. As I start to increase the deviation with the test button hold, you'll see some spikes appear.
Ugh. Yeah, it's getting
Right.
ugly.
Well, these are called, what we're looking for is the Bessel null, which is when the center spike starts to drop. I'm going to let go.
Yeah,
Do it
to be sure, the bandwidth that you're seeing is one channel.
Right.
This isn't the entire. You're not looking at harmonics. You're looking
So
at
yeah,
one
these aren't
channel.
harmonics. No.
So there.
So this
that's
would be
the
the-
null.
Okay, awesome.
So once you've achieved that null, you've set the Bessel null for the tone that's being sent, and this is based on the frequency of that tone. All right, that the TNC is sending. Different tone frequencies will give you a different deviation when you find the null.
Can,
So
can,
I'll,
can you
go
turn
ahead.
it down and sweep across from too low to too high again so we can see
Yep.
the null?
so I'll start at 0.
And then when you get done, explain what a Bessel null is.
See the dip?
Might be it. Yep, I see it in the middle. Yep, going
That's
away.
the dip. That's the Bessel null.
All right.
But,
So
but why do we care? Is
we
more the
care
question.
to set an intentional deviation. It doesn't matter as much with a legacy mode. I mean, 1200 baud AFSK, right? If you're sending that mode through the microphone port of a radio, then the radio is going to really do all of the deviation, automatic setting, and limiting, okay? But once you start to use 9600 baud frequency shift keying, say with a radio that has a data port, or you've hacked a direct drive into your FM radio to bypass all of the audio stages in the transmitter, which is another way to get a 9600 baud capable radio. The deviation is up to you, and so the channel bandwidth that you occupy is up to you as well. So instead of 3 kilohertz for AFSK, I'm going to shift this to 9600 baud GFSK now. You can hear it's a lower tone, right? And the shape
So
of the
the-
waveform is different.
Yeah, so the demands on the airwaves at 9600 baud require much cleaner, unprocessed signals from the radio than do 1200.
Really, you want to avoid all of the low pass and high pass filtering that's happening in the analog stages of your FM radio, because it's going to eliminate really important parts of the waveform and make it almost impossible, well, really impossible to decode. Because the FSK waveform really needs you to be able to drive the frequency of the FM transmitter almost directly, meaning down below 300 hertz, which is where the high pass filter on most FM radios is going to start to cut. So your voice is high pass filtered by the radio as you speak into the microphone. You want to avoid that. You also want to
So
avoid
doing, I was going to say, so doing this work with the Bessel null is trying to find the strongest signal to noise ratio, trying to get the most of your message communicated to the far side as possible.
in an indirect way. So I'm going to do it again at this lower frequency in 9600, and I'll show you
So there's
lower
two
tone.
two
Here's the
questions.
dip.
One of the answer is this is math. It's not really telling you anything about 9600 baud. It's directly related to the frequency of the tone that's being transmitted. So you're trying, and the deviation is the amount of bandwidth occupied by the FM modulation.
Like the
And
entire
there's-
envelope, right? I mean, like I've seen where folks use Bessel null to calculate how much deviations like in an AM or an FM signal, and it looks like
Yeah.
you're just doing that to tone to test here. That tone that you're playing though, you're doing a single tone, or are you doing like a mixed tone?
Nope,
which would have
it's a single tone. And the different peaks you see rising and falling are a product of how that tone is modulated over an FM.
what's like the sum and the difference in the third order, right?
Right, exactly. Yeah, and the first Bessel null happens when the deviation is 2.4 times the frequency of the tone. And our goal when we're using 9600 is to use at least 2400 hertz of deviation. Not really a whole lot more, because as you get the signal wider, it might not fit into the intermediate frequency bandwidth filter at the distant radio, and you might actually
With its receiver, yeah.
yeah, the receiver might have problems with it. So I'm going to set up the TNC now to send a burst of packets so you can see the shape of the occupied bandwidth on the SDR when you send a bunch of packets in 9600. And I'll show you what happens when you change the deviation. All right?
Sounds
you can
good.
Speak amongst yourselves.
Well, that's good. While you're getting that set up, and just holler when you're ready.
Yeah.
We have some questions that I wanted to go through. We're up to an hour, so we have a little bit of time left. But
Yeah.
let's see. All right, the Air Force questions are burning a hole in several people's pockets. What
Awesome.
did you do in the
Especially
Air
Jim's.
Force? When were you in it? Yes, I am Air Force curious because I was in the Air Force too.
Yeah, I was in from 01 to 2021, so 20
Oh,
years.
you did good for you.
Full
Yes, sir.
stretch.
I was
And,
I was in the 80s, and I was married to a woman who was incompatible with the military lifestyle. So it was either get rid of her or my Air Force career, and I eventually ended up doing both. So
Oh, well, I'm
I was
guessing you
stuck
made
with
the,
her for a while, but yeah.
So you made the right decision first.
Oh yeah,
yeah,
I had to get
well-
I had to get out. I didn't want to go to jail.
Well done to you.
Crazy.
So I was in the Air Force 2001 to 2021. I used ROTC to pay for college.
Oh, very good.
I was a navigator first in the F-15E, and then I went to pilot training, and I flew the F-15E and the T-38 as an instructor towards the end.
Okay, your cool points just went up by
The
3
T-38
orders
's
of
the
magnitude
Texan?
right there.
No,
That's
the
the Texan,
T-38
right?
is the Talon.
Talon.
It's the old 1960s supersonic jet trainer.
This is what the astronauts were playing with during a
Yeah,
Apollo
NASA still
program.
flies them. It's
Yeah.
old.
Very cool. All right,
People who
on
live in
topic.
Houston and Nassau Bay see them all the time.
Let's see. So application software. Don is asking about that. Is there any application software that you use with this specifically that you like? Specifically, BBS and terminals is what he's
Yeah, I'll
mentioning.
let Tad start with that.
Well, so the Tarpon project uses GAPPQ's network stack with chat and his BBS, and we wrote our own user interface called Tarpon Home, and I can show you that if I share my screen after Nino gets done with his thing. So in practice, I can't answer that, Don, with anything useful, because we're basically, if you're running a Tarpon node, you're in a Tarpon network. It doesn't expect to communicate with anything outside of a Tarpon network, and that's where we are right now. We're still working on it, and we will probably work on it until I am cold.
We have a real break-in right here, real quick though. Jim, did your coffee mug just say Chick Power,
No.
or can we not discuss that?
It says
Chief Perry. Oh, I saw CHIP circle with your thumb.
no.
over
This
it.
is one of the fire department mugs the old lady had gotten me. The coffee and ham radios one's in the dishwasher at the moment. So
All right, so I think I'm about ready to show you guys something. I'm going to set up, I've got a little batch program that will blast a bunch of packets to the port that's hooked to the radio just to get it to send data across so we can look at the spectrum. So I'm going to start that, and we'll go over here and look at the spectrum. That's the GFSK 9600 signal when the deviation is set well. It's nice and round. It's got those little side lobes, and the whole thing fits into a 20 kilohertz channel, right? It fits into old wideband FM, and that's the goal, because your intermediate filter at the distant radio is going to limit anything outside of that bandwidth. So I'm going to do that little batch send again, and I'll play around with the deviation and show you the difference in what the occupied bandwidth looks like. All right, here we go. Let's see. Starting the transmit again. Just sounds like white noise. I'm going to drop the bandwidth or the deviation. All right, and you can see deviation set too low. All of the energy in the signal goes to the carrier, to the center of the spectrum displayed there, as you set deviation lower and lower. And to that extent, your signal to noise ratio at the distant station, at the receiving station, is going to be much worse when you have your deviation set too low. Okay, so you want your deviation set pretty close to right. It doesn't have to be perfect because either the link works or it doesn't work. But there are alligators at both ends. Deviation too low, you're going to lose a lot of signal to noise ratio. Deviation too high, you might go beyond the bandwidth capability of your receiving station. So we've provided that Bessel null tool, the tone, to get you close. Does it have to be perfect? No. You can also just sit there and spin the dial on the TNC until you get close enough and both stations are happy, right? All right, let's see. Let me go back to my camera. Stop screen. Any questions on that one?
No, that explained it very well. Let me see if there's any other outstanding questions that we've got here. Don, who is our favorite troll, was asking if you have played with the Nino device with an N76, the Vero N76 radio, or its Balkan equivalent of UV Pro.
I have not, but I hear those things are fairly capable. But what does he know? What's good about it?
Don. Well, actually, I think Don said earlier he's using the Nino with the Bluetooth KISS functionality.
Oh, that's cool.
In the N76.
So if you use an AX25 mode with the TNC, meaning traditional 9600, I'm going to try to move my camera back to me. If you use like G3 RUH 9600 or 1200 AFSK with AX25 encoding, meaning how the bits are handled, it'll be compatible with most of the available commercial FM modems. Because as far as I know, there's not a commercial manufacturer that will make an IL2P modem in one of their devices. It's all AX25
right.
modems.
So Scott is asking, are you guys looking at supporting ARQ/FEC?
Yeah, so IL2P, which is Improved Layer 2 Protocol, which is something I drafted and wrote and integrated into the firmware, uses forward error correction. The packet lengths are just a little bit longer than the AX25 packets to add that forward error correction so as not to use too much more time on air. And it's very effective. It adds margin to your link when you use it of a several dB. ARQ is the next level in the chain. The TNC doesn't know about ARQ. That's acknowledging the packet that was sent by number, meaning the sending station puts a serial number in every packet, and the receiving station says, I got packet 1, packet 2, I got packet 4, hey, where's packet 3? And then the sending station sends packet 3 again, right? That's supported by the next layer in the communication stack generally.
Let's see. I'm not sure if he's trolling or not. I feel he's trolling.
And he's just pulling your leg. Who cares?
Yeah.
That's all he knows how to do.
Yeah. Just everybody acknowledge our younger troll, but still a troll. Great.
Right, he's the Don in training.
Oh, he's the DIT. Don in training. There you go. I like it.
So if I had a pair of these things, what would I use them for? We talked about mail a little bit, but are we talking about like, can you do a file transfer? Can you do mail? Can you do MCOM? Like connect this, like here's all the ingredients. What's the cake look like? What is the cake? What is a cake?
Yeah, that's totally up to the user, right? As this hobby kind of goes, make it what you want to make it. There are people using it for MCOM in different areas. People use it for WinLink. You can use it to send mail to WinLink stations. I think that's used for MCOM once in a while. You can send files through the G8BBQ bulletin board system. Again, this all requires a little bit of software in another computer, whether it's a Raspberry Pi or a Windows computer or a Mac computer. Most of them have software that will talk to a KISS TNC in KISS mode. You can think of KISS as being the driver, like a Windows install driver. So because the TNC speaks KISS to the host computer, it doesn't need special software drivers to interface with any program that uses a serial KISS connection downstream. And there are a handful of them. If you're interested in APRS, there's a handful of APRS programs that
Pinpoint is outstanding.
Yeah.
It's a Windows program. I don't know that it's available on other platforms. And then there's Xastir. I don't know how you say that. XASTIR.
And then there's Yak, which is yet
Yak.
another APRS client. There's a bunch, right? There's some Linux
Direwolf.
command line programs that can do it. Direwolf's got its whole thing. It's a sound modem that uses your sound card and provides a KISS interface virtually to host programs. But
I think Direwolf can be operated without using their built-in software TNC, though.
Oh,
It has
Yeah,
capability
Direwolf will talk
beyond
to a
that.
KISS modem. Absolutely. Yeah, I've used
interesting.
it.
All right. And then, if you want to make a bulletin board system like the old style packet stations in the 90s and the 80s, there are simplified install scripts for that actually generated by some of the members of the UK amateur radio groups that use the TNC. But really, the object as it exists is optimized to be integrated into the Tarpon style appliance, which is typically a Raspberry Pi with the G8BBQ stack. It's fully compatible with other KISS applications. Bottom line on all this is you have to get into the weeds a little bit to make this part of the system that you envision. And that's a little bit intentional to get people out of the consumer mode and into the systems administrator mode and understanding exactly what's happening with the device and the radio.
Yeah, we want this thing to be educational.
And that is what I would tell the Grouch in New Hampshire. So these devices give you a
Hey,
single
Paul.
packet mode, but you can't use the same stuff with FL Digi. Maybe he's really confused.
Can't you do the same stuff? Yeah, you can do a lot of the same stuff, but not
You
as
can
good.
do similar stuff.
Yeah.
The point is, once you have the TNC set up, so you've spun the dials to where the settings are right, and the other dial is TX delay, how much time is spent sending out zeros and ones before you send the packet. Then you leave it alone, and you focus on the upper levels of your project. Also, you could use FL Digi as a keyboard to keyboard, I'm the user now kind of thing. Same with
I'm the
Direwolf.
user now.
But if you want to run a station that has, let's say, half a dozen different modems on different radio frequencies and different bands, that's really hard to manage when you're using software that's running in a host operating system, right? How many instances of FL Digi do you want to run? How many modems do you want in QT sound modem? And which one is hooked up to what? And how am I going to route all that? When you get into more than one modem at a station, it's, in my perspective, it's way easier to have a device that is, okay, this is what I hook up to 70 centimeters. This is what I hook up to 2 meters. Here's my 30-meter APRS modem. It could all be hooked up to the same Raspberry Pi or whatever computer you've got, and then you can do whatever you want with the data that's going in and out of it. So the value there isn't necessarily in your single user, I turn on my ham radio station, I sit there and use it. It's in, I want to build a system that has more capability.
All right. Now, the open source people are just all conflated and getting in a tizzy. And if they apparently weren't listening, at some point, y'all are going to open source the code.
Firmware, probably,
the
yeah.
firmware code. Probably. Now it's probably. He's backing off on that a little bit.
No,
you
it's
open source.
exactly-
The thing is, yes, it's definite. The question is, do you do it while Nino is still paying attention, or after he's gotten off to do something else?
Moving
Right.
on to a different
I
project.
fully expect that when Nino gets into autocross and starts building the big engine and all that, NinoTNC will become open source. But
Right.
you know, what were you restoring, a MiG or something? I can't remember what that was.
Sweet. Can I come over, man? I'll help. I'll hold the wrench. That's all I need to do is hold a wrench. I'll hold a wrench.
Yeah, I'm not working on any MiGs.
Or autocross.
No, I've got old cars and no planes. I'll fly if someone else is paying for the maintenance and gas.
Amen, brother.
That's how I do it.
The
My plane, not my problem.
That's right. Yeah, we'll open source it. The firmware will be open source probably soon, and I just want to get the code up and my comments up to my own standards. The project has been going on a few years, and for a lot of the years, it was in a growth mode in terms of capability in the firmware. There's a lot of functionality in the firmware. We've added more modes. The thing that I wanted to do as we added modes was make them work well. And so every time we added a mode, I would go through months of optimizing the mode. And I've got a few simulation programs that I kind of hacked together to make the modes more sensitive, make them more reliable. And all of that tuning is close to done. And once it's done, then I'm done. And I'll set it free and people can do whatever they want with it. They can probably make it a lot better. You know, I'm just not there yet.
Very cool. I think you guys have done an outstanding job, both with the hardware, the kit, the documentation. Tad is going to have a melon that will not fit through the door after this stream. But both of you guys, it's just an outstanding project. And if you've never done a kit build, when you open the package of parts from Mouser, and you're like, oh my God, this is going to be, but it's really not. T.O. and I built one after he got all the right parts from Mouser, because they kind of shafted him at the beginning. But we watched T.O. build one on stream, and you know, it's not, the instructions are step by step. It's a great kit to build. And somebody just mentioned in the chat, and we've all said it before, ham radio is about experimentation anyway.
Yeah.
So with something like an N76, right, which is a sub $200 HT with a Bluetooth TNC built in.
Yeah.
I mean, you can do a lot of cool things, experimentation things, and then maybe you decide you want to get into the Tarpon network and go further. But I mean, it's an interesting thing to mess with. Yeah, it's older technology, but I think you guys have put a little fire back in packet radio. Honestly.
And that's how we get it to be new technology.
Stirring the competition.
So
right,
I have a small demo to do for you when you get to it.
Okay, I saw a question go by. Why are we focusing on 1980 speeds?
Because the government says we have to.
Well, 1980s they didn't use the speed right. We can do better.
Here's my thoughts on that. The project started as a way to utilize cheap, surplus, secondhand voice radios to push bits through the air. Okay, there are currently projects to make wideband modes. It takes special hardware. It takes other stuff. There's some really cool projects out there doing that, like New Packet Radio. And if that's where you want to go, hey, I want a really fast link between these two mountains on this valley. Have at it. That stuff's out there, right?
Yeah.
It's just not what this project is. This project, the highest speed mode is 19200, so that's bits per second gross. That's very delicate. It needs a really good system at both ends in terms of radios and good signal to noise ratio. That's about as far as we're going to get in the available bandwidth with our target radios. When we go into wider bandwidth modes, let's say you have 100 kilohertz or 500 kilohertz or multiple megahertz on some of the centimeter bands, it's different hardware, different kit to do that. And it's a totally different level of investment if you just want to tinker around with data modes over the radio. because there's not a whole lot of off-the-shelf stuff that's going to do that. There will be, but it's
Right.
going to be less dynamically flexible, right? You can use this to do APRS on 30 meters. You can do APRS on 2 meters. You can use Tarpon networks on 6 meters, 2 meters, 70 centimeters. And why do I care about sending hundreds of bits per second or thousands of bits per second? Because that's still useful information. Most of the communication that we do on these things with our family and friends is about 100 bits per second in the text mode, right? So humans talking to each other at a few hundred bits per second is still useful communication.
Very useful. Yeah,
And
absolutely.
I find that there's something artful about doing that simply and well. And that's why
Doing
it's
more
a
with
hobby.
less is on.
And
Exactly.
doing it over ham
Yeah.
radio and
Yeah.
involving many people.
We're doing it over
possible
HF
projects.
with solar maximums and minimums to deal
Yeah.
with and unholy
The
distances.
crappiest frequencies
Yes.
over the
And
longest
it's-
distances.
That's where I get value out of this hobby,
Yeah.
right? So that's why it looks like that.
We're doing it harder because we freaking can. That's it.
That's right. Yeah.
That's the answer.
It's like, well,
Yeah, why do it with 2 radios when you could do it with 70?
Right? That's right. There's the engineer right there. Let's overcomplicate this with multiple redundancies. Thank you.
Anything worth doing is worth overdoing.
that's right.
Exactly right.
I got
Ted, you have a
video.
demo for us real quick? Yeah, we're getting close to the end of the show here too.
So that over there in the corner, it's my packet node. You see the lights blinking?
Blinky
Yeah, on
lights.
the white shelf. Yep.
Yeah.
That's actually my old school packet box. That's my new school packet box. Working on it. And these 4 radios over here are actually part of the same network, same box as that. I've got USBs run over the door down to the other side. So I can actually have 8 NinoTNCs on my packet node with 8 radios. And it wouldn't fit on the one shelf. So what I'll leave this to YouTube. If you go to TARPN there's links. There's a network button, but there's also a picture right in the middle of that front page of a chat using something that looks like old school IRC. You could actually bring that up.
I got it, Jim.
Just tarpon.net. And there's a picture of the NinoTNC. If you click on that, it takes you to a NinoTNC specific page. If you click on the packet node, in the middle is a chat, and that's what our user interface looks like. So you can see the stations that are actually online on the right and how long it's been since they typed on.
Holy IRC.
Exactly.
It
Yeah,
does. It
that's
does
what
look
we-
very
that's what
much
we
like
copied.
it. Yeah.
Exactly.
Yeah.
So go back one page, and you see the packet node. It looks just like the one in my house here on the lower right. If you click on that, it takes you to a page that describes what that looks like. If it
Let me
works.
get that down a little bit. That was
Did it
too
work?
big for the whole thing to fit in one screen.
What if you click?
There we go.
If you click on that picture? If you click on the picture, does it go to the other page?
Oh yeah, hang on. It's a stupid StreamYard thing.
There you go.
It opened in a new tab, and then I had to
It
share
opens
that
it.
tab.
Yeah.
Yeah, so that's a block diagram of what our Tarpon packet node is. Okay, pop back one. That's hard to do, I guess. Got to go to the other, and then click on the TNC. There's a shopping list and videos of how it works and all this stuff. Whoops, X tool. I don't know where that came from.
Yeah, it's an ad for the video I just clicked on for you. There's your
He's-
video.
Yeah,
He's not
that
signed in.
that just shows you a little bit of what the thing looks like when it's operating. So bot back to the Tarpon homepage.
Are those mortises or did you use butt joints? I'm ashamed.
I didn't
Those are
build
butt
it.
joints.
Someone else built
Those are butt joints. Damn it.
Yeah, KM4EP built that one.
No, there's lap joints and mortises, and
Yeah, I guess so.
So some of the stuff, the little wood bits that are glued in place to hold the battery from sliding and the power supply from sliding, that was that stuff just to adopt the KM4EP made a box that has 3 shelves on the top.
You fixed it so everything doesn't slide out. No, that's a decent setup. I like that shelf.
So
the way
the whole
that's laid out,
system-
it's good.
One of the things I really kind of, I poke at with people if they don't do it this way, is the packet node box should be eminently portable. So everything's attached. So if you put it on its nose, it won't fall out. And you could pick this up, like if let's just say an emergency happens in the Rex Hospital, which is just south of me in North Raleigh. and the UNC main in Chapel Hill are actually in the same hospital system. So let's say the internet's gone, the cell phone's gone, we have to use ham radio to link the two hospitals together. We could drag some of our nodes out of our houses and set them up in hours to link the two hospitals together for sending Excel spreadsheets back and forth, for example, in a true emergency. But the whole idea that the thing is portable is also good, because you don't have to know all about all levels of the project, from Linux all the way up to 440 Yagis, in order to build this, because we have a team. The club is enormous, and online you can get suggestions, but in person we can all show up at the same house to work on something. But the neat thing about having the thing portable is you could pull it out of your shack and bring it to somebody else's, and maybe someone else is the guy who's the one who can debug the thing for you. So that's with the box. Now, if you go back to the Tarpon homepage and click on the TNC, yes, we do have bugs on our network. Thank you, Vance. The same guy who did the Android walkie-talkie project it also has a mud on his node. Yeah. So if you go down and you see the TNC on the lower right, you can click on that, and that brings you to our NinoTNC page. See the TNC on the right? Whoop,
the blue one?
That one. Yeah, click on it.
And it's going to open a new tab.
Yeah, there you go. Yep. And there are that's the NinoTNC page. If you scroll down, there's an advertising shot.
A money shot. There you go.
Yeah, that's your elevator speech.
That's right. That's right.
And yeah.
So the availability of the boards right now.
Yeah, they're on hold because we're switching designs slightly to use the 3-pin part and new documentation and all that. And it's all hobby project stuff, so bear with us. We're not making any money on this. In fact, the cool thing about this TNC is that because we're practically giving it away. We're anybody that feels like it could help the project by giving us hints, and it has happened. There's a list of call signs in the upper right of a couple people that have participated in this, given us clues that majorly affected the design. One of the things you'll notice about this TNC is that all of the controls to operate it from day to day are right out front, including a light that tells you got a good packet. There isn't another TNC in the world, even that fancy time wave PK232 does not have a light that tells you got a good packet. In 40 years, we couldn't put a light on the TNC to tell you got a good packet.
Well, Tad, I think in 40 years from now, they'll be selling these at Hamfest for,
So we have
$40.
If you go to the operations page,
This is a Nino TNC from the 2020s.
If you go to the operator's manual, don't do it now. But in there, right up at the you can scroll down a little bit. Then you'll have to find it. There's information about what if you want to make your own.
There you go, Don. That's the one.
And that's we're serious about that. And there's several people have already made their own PC boards, ordered their own processors, and programmed them themselves. And that's fine. In fact, we're even okay with people going out and making money on these things. If an MFJ wanted to come out of the woodwork and sell Nino TNCs, all we're asking for is that you put Tarpon on the box and use our PCB.
The UK clubs have built hundreds of them. They've ordered the PCBs. They've fabbed the PCBs themselves, and there's been some built in mainland Europe. There's been a few clubs building them in the United States in terms of sending the board order and having boards manufactured for them to
and we're okay with, we don't get any proceeds from that. So if someone's club really wants to have 100 of these TNCs for somewhere in the order of $25 a piece, they can do that.
Less than that.
You got to remember the CPU, the board, and all the parts.
Oh yeah. The boards be a couple bucks a piece when you order them at quantity.
So that really, we're out of the loop in that. We have requirements about publicity. We want people to know that we invented this. So our call signs, and Nino's call sign, the name of the product, and the fact that it says Tarpon on it. On the
people that did all the heavy lifting, yeah.
Yeah, so that's it. I mean, basically exactly what the TNC2, well, excepting that Tapper, I think, got proceeds from those. I'm not really sure about that. Don't quote me. But anyway, but the fact is that that's how you make this explode, is you make it cheap and you make it available to people who want to make them for a couple dollars profit. I think that would be great. We need, make the difference between the A3 and the A4 is that the A4 has better switches for controlling the audio paths. Other than that, they're in the same firmware. But anyway, the availability of a TNC that can do from 300 to 19.2 kilobaud for $40 is huge. And not only that, if you want to make a packet node for real, to make a real network, you could put 10 of these on the same Raspberry Pi. And the configuration of them is right on the board. You do not have to go into anybody's software to set the TX delay or set the baud rate. It's all on the box, on the device. And it has great displays and controls right on the front edge of the box. So it's really easy for someone to make a 3D printed housing for the.
Look at Tad pimping the multicolor housings. Go back to that first one you held up there.
He's got time.
I printed. T.O. does not have a 3D printer. He has a religious thing that keeps him from buying one. So I gave him. I printed
Catholic
a couple
guilt.
for him, but they're just black.
Yeah, I actually didn't do the coloring on this one.
They're basic black.
Someone brought this to a meeting and gave it to me.
I might steal some of Chris's nail polish and just color it in.
Yeah.
I put one in a box, 2 years ago. It lasted for 2 minutes before I had to take it out because I'm always adjusting, tuning,
parts,
replacing parts, testing parts. Mine are all bare.
Yeah, so
Depends on which part of the hobby you enjoy.
There's actually you'll note that TNC, the node, packet node here at my house. I showed you all those TNCs are bolted from the bottom, just like this. They're just sitting on cards. Pardon the Velcro stuck to the bottom.
Well, the beauty of that is they won't slide all over the table when you're messing with them.
Yeah, and they Velcro into the box.
Because every time I was messing with mine, case or not, the USB cable was wanting to drag it all over the place.
Yeah,
at least you could take a piece of plywood or cardboard and stick a thumbtack into it.
Right.
The Dave K4TBZ made a little plastic bracket that fits on the bottom of the TNC that gives a big slab for you to Velcro to, and that's the way mine are. Actually, no. Intermittent. I actually intermediate box, not the one I'm using, but most of the boxes that KM4 EPJ made had TNCs that were Velcroed in with little plastic slabs. If you go on the NinoTNC website, I believe there's a link to the plastic slabs that Dave made. Actually, if you go to the ninotnc.org or .net or .info or .com, any one of them, you go to the operator's manual, scroll down, you'll find the some 3D printed stuff, and there's a separate web page that shows pictures of the 3D printed stuff for the NinoTNC.
We have a super chat from Don. Appreciate it, Don. Thank you very much.
Thank you.
Our favorite troll and a favorite subscriber. Guys, we're at 10:30.
All right.
And we lost breakfast. Ape. I don't know what happened to him. He might have had a. I wasn't going to say it, but it's probably what happened. He had to pee. Bellis, thank you so much for coming. Y'all a great job.
Thanks very much for hosting us. That's awesome.
And Tad the cat adds 3 dB to your presentation.
Where is the cat? Where's the cat?
There was talk in the chat that she might have been licking her business while you were talking too. I didn't see that, but I wasn't looking.
It's a he anyway, but that's beside the point.
His business, her business, whichever.
And he's missing some of his
none of my business is what it is.
I mean,
yeah, he's missing some of his business.
Right. A brother can wish.
Hey, thanks, guys.
Used to taste like.
You got anything else, or?
No, we're all good. All right, thanks everybody.
Guys, thank you very much for coming, and all y'all out there, thank you for hanging out with us. Appreciate it.
Yeah. You're welcome.
I am hitting the button. Boom.